Today we will solve GATE 2026 EC analog problems. In the first question, they have given that when the switch is open, the output voltage is X volts. We have to find the relation when the switch is open, the output voltage is X volts. Let us say when switch is closed, the output voltage is V0 is some Y volts. We have to find out the relation between these two. So when the switch is open, the circuit will look like this: minus 1 kilo ohm, 3k, and the input is 1 volts. We know that this is a simple non-inverting amplifier and the gain of this is 1 plus R2 by R1 times of V in. Here R2 is 3k, R1 is 1k. So the output voltage is 1 plus 3 by 1 into 1 volt, that is 4 volts. This one switch is open. When switch is closed, a circuit will be 1 volt, 1 kilo ohm, this 1 kilo ohm will not come into picture because it will have a short circuit through this switch. The current will flow through the least resistance path. So the 1 kilo ohm resistance will not be there, only 2 kilo ohms resistance will be there. So now the gain is 1 plus 2 by 1 times of 1 volt, that is 3 volts. If this is X volts, V0 is 4 volts, which is X volts. V0 dash is 3 volts. This can be written as 3 by 4 times of X volts. 4 will get cancelled and 3 volts will be the answer. So this relation will follow: 3 by 4 times of X. In the next question, they have given VBE of the BJT is 0.7 volts, beta is 99, VCC is 12 volts, input voltage is 3 volts. So before solving this question, we have to check whether this loop is in negative feedback or not. To do that, what can we do is we can break the loop here. If I increase this node potential, this node potential will increase, and also this will increase, and here it will decrease. The phase between base and emitter is 0 degrees, so if I increase this node will increase, and here we are giving input to negative terminal, so the output will decrease. So this is an negative feedback. So because it is in negative feedback and the op amp is ideal, that is open loop gain is infinity, we can assume that this is virtual short. So the voltage here will be 3 volts, and the emitter current will be 3 milliamps. 3 by 1 kilo ohms, 3 milliamps. And we have to find out the value of I0. I0 is the base current of the BJT. I0 is IB, which is IE by beta plus 1. 3 milliamps by 100, 0.03 milliamps, that is 30 microamperes. So the answer is 30 microamps. In the next question, they have given a plot IC versus VCE. We have to find out the relation between the early voltages of two MOSFETs. BJT1 they have given like this, and BJT2 ideally it should be like this. It should be flat with respect to VCE, and because of the early effect it will have a finite slope. They are representing the finite slope with the early voltages. The early voltage of BJT1 is VA1, and the early voltage of BJT2 is VA2. We know that lambda channel lambda is 1 by VA. Clearly we can see that slope of BJT1 output characteristics is greater than slope of BJT2 output characteristics. The output slope is higher for BJT1 compared to BJT2. So lambda 1 is greater than lambda 2. So because it is an inverse relation, VA2 will be less than VA1 will be less than VA2. So VA1 will be less than VA2. And here if we see, none of have a infinite slope. Both VA1 and VA2 are finite. Both VA1 and VA2 are finite. In the options it is VA2 is finite. So the correct answers are C and D. In this question they are asking the small signal gain. Small signal gain V0 by Vi. We have to note that in order to find the small signal gain, we should know the DC current first. First point is to calculate the DC current. From this we have to calculate the DC parameters GM, RCE, etc. Then we can do the small signal analysis and find out the small signal gain. So what we will do, we will calculate DC current first. To calculate DC current we should know VBE first. So initially assume that IB is 0, beta is very high. Then we can apply voltage division rule. From this we can find out VB. VB is 25k by 25k plus 100k, 125k into 12 volts, which is 12 by 5 volts, which is 2.4 volts. So we will get VB as 2.4 volts. In the question they have given that VBE is 0.7 volts. So the potential difference between base and emitter is 0.7 volts. So the emitter potential will be 2.4 minus 0.7 volts, which is 1.7 volts. Now we got emitter potential as 1.7 volts. The emitter current is VE by the resistance seen from the node. So IE is 1.7 by 0.5k plus 1k, which is 1.7 by 1.5k. IE turns out to be 1.133 milliamps. From this we can calculate IC. IC is alpha times IE. Alpha is beta by beta plus 1. Here beta is 99. So we will get alpha as 0.99. From this we will get IC as 1.122 milliamps. So as said, first point we have find out the DC current. After we find the DC current, we can find out the small signal parameters. The small signal parameter required to calculate gain is GM. GM is given as ICQ by VT. VT is 25 millivolts. If we plug these values, we will get GM as 44.88 millisiemens. So the small signal gain of this is minus GMRD by 1 plus GMRS. If the capacitor was at this node, from this node to ground, the gain will be simply minus GMRD. But here the bypass capacitor is connected to the 1 kilo ohm resistor. Because of that, this 500 ohm resistor will contribute to gain. It will decrease the gain by a factor of 1 plus GMRS. This is standard thing. So the gain is minus GMRD by 1 plus GMRS. We know GM, we know RD and RS is given. If we calculate this, the gain will come out to be minus 9.57. So but when we see the options, there is no option in which 9.57 is there. 9.1 is there. So the thing is, we have not included the output resistance of the BJT. When we see here, they have given early voltage as 100 volts. So the slope is finite. It doesn't have an infinite slope. So RCE is 1 by lambda IC. So the output resistance is 89.126 kilo ohms. When RCE comes in parallel with RD, the equivalent resistance will be less than 5 kilo ohms. So the output resistance will be less than 5 kilo ohms. So this will come out to be 9.1. You can calculate it and you will get 9.1. So the answer is minus 9.1 into the input signal has two frequencies, A cos 10 to the power of 5t plus B sin 10 to the power of 7t. They will get amplified by a factor of 9.1, which is the gain. And this is a simple question. We clearly see that the op amp is in negative feedback. So this will be at a potential of 0 volts, virtual short, and the current flowing in 1 kilo ohm resistance will be 2 by 1k, which is 2 milliamps. The current flowing in this 1 kilo ohm resistance, will also be 2 milliamps. So the node potential here will be minus 2 volts. The current flowing this way will be minus 1 milliamp, and this is 2 milliamps. The current flowing in the upward direction will be 1 milliamp. Ix is sum of these two currents, 2 milliamps plus 1 milliamp. Three milliamps. Ix is 3 milliamps. Ix is 3 milliamps. This is simple KCL. And this question is a standard question. In this question you have to just write down the current equation and equate the, we'll do step by step. Let us say the current flowing is ID. So Vg is VDD minus the drop across the resistors, that is 1 kilo ohm times ID. And also we know that ID is half K times VGS minus VTH whole square when the MOSFET is in saturation region. Here it is clear that MOSFET is in saturation region. So Vg is VTH plus square root of 2ID by K. So Vg, we can equate these two equations. Let us say this is 2 and this is equation number 1. VDD minus 1K into ID is equals to VTH plus square root of 2ID by K. VDD minus VTH is equals to 1 kilo ohm into ID plus square root of 2ID by K. Plus square on both sides. Before applying square, I have modified this term. I have brought the ID term to left side. So 16 minus 1K square into ID square minus 8K into ID is equals to 2 will get cancelled and here ID will remain. So ID square minus plus 8K plus 1 times of ID minus 16 is equals to 0. If you solve this, you will get ID. So earlier I have written the equation wrong. So if we look carefully, it is 4 minus 1K into ID, A square 16, 1K square into ID square minus 8K into ID. Here 2 will get cancelled. It will be ID by 1 milli, that is 1K times of ID. This is 1K times of ID. When it comes to left hand side, it will become minus 9K times of ID. Now if we solve, we will get two solutions, 6.5 milli and 2.43 milli. If you plug the value of 2.43 milliamps, we will get Vg as 2.55 milli. It will match with the given output range 2.5 to 2.6 volts. So the answer is 2.55 volts. In this question they have given all the resistance values as 50K and they ask to find the closed loop gain as V0 by Vi. Because it is a negative feedback, it will be virtual short and the current flowing will be Vi by R1. so the current flowing in the R2 resistance will also be Vi by R1, and the node potential here will be plus minus Vi by R1 times R2, and this will be negative sign. So the node potential at this point will be minus Vi by R1 into R2. So if I apply KCL at this node, the current flowing is Vi by R1 is equals to the current flowing in R4 resistor and the current flowing in R3 resistor. So the current flowing in R4 resistor will be Vi into R2 by R1 R4, plus the current flowing in R3 resistor will be minus Vi into R2 by R1 minus V0 divided by R3, which is minus Vi into R2 by R1 R4 minus Vi by R2 by R1 R3 minus V0 by R3, Vi by R1. If I bring Vi terms to one side, it will be 1 by R1 plus R2 by R1 R4 plus R2 by R1 R3 minus V0 by R3. If I take R1 common, V1 plus if I take 1 by R1 common, it will be 1 plus R2 by R4 plus R2 by R3 minus V0 by R3. Since R1 and R3 are equal, they will get cancelled. So V0 will be V0 times V0 will be minus Vi times 1 plus R2 by R4 plus R2 by R3. Because they are equal, it will be minus 3 times Vi, and in the question they have asked only the magnitude, so the magnitude of the gain will be 3. And here comes the last question. Here they have asked the maximum output voltage V0 of T, and the cut-in voltage of the diode is given as 0 volts. For maximum voltage to occur, input has to be at maximum. Let us say input is 6 volts, and in this case the diode D2 will be reverse biased. So the circuit will look like this: 10k, 10k, and 2 volts and 6 volts. This is the output voltage V0 of T. To find out V0 max, we can simply apply superposition. This will be 6 by 2 plus 2 by 2. This is 3 volts plus 1 volt is 4 volts. 4 volts will be the maximum output voltage. So we have solved all the 8 questions. This is the simplest our paper I have seen for analog electronics. All questions are easy you just have to know KCL, KVL. Yeah, that's it. Thank you.